Let's take a look at the problem valid anagram. Given two strings s and t, return true if t is an anagram of s and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all of the original letters exactly once. Example 1, they've got the word anagram for the first input of s, anagram, and then t is set to nagaram. And these are going to be anagrams because if you rearrange these letters, you can make both words. Example 2, you've got the word rat and car. These are not anagrams because they have different letters, right? There's no T, for example, in car. The constraints are such that the length of T or S are going to be between 1 and some giant number, and S and T are going to consist of lowercase English letters. All right, let's dig into the theory here. So we're going to actually use the inputs that they gave us, which is the word anagram and nagaram as an example of a valid anagram. And when you look at these two, the first thing you kind of want to know is, all right, well, how do I determine if it's an anagram? The name of the game is really all about character counts. What do I mean by that? So if we look at the first one, right, anagram. So if we look at A, how many of these A's are there? So we've got 3. Okay, so let's go to the next character. We've got an N. How many N's are there? Looks like we have 1. And if we look at the G, how many G's are there? Looks like just the 1. R, looks like just the 1. A, we've already counted that. And M, we've got just the 1. And if we look at the word nagaram, we're actually going to see pretty much the same thing. So we've got N, how many of those do we have? We've got just the 1. A, we've got 3. The G, we've got just the 1. R, we've got the 1. A, we've already counted. And M, we've got the 1. So the way that we're actually going to store this as far as data is concerned is going to be in dictionaries. So the dictionaries that we're going to store the character counts in is going to be a dictionary of character to integer. An integer is going to represent the actual count or occurrences of a specific character. And from there, we can compare the two dictionaries to see if the counts are the same, and if they're equatable, then we know that we have, or if they equal each other, rather, not if they're equatable, we know that we have an anagram. If they don't, we know they're not anagrams. And so the time complexity of this is actually not going to be O of n, as you might think, because you might think about it, like, what does O of n represent? Well, we actually have 2 inputs, right? So it's a little bit deceptive. We've actually got, let's say, for example, we allow the length of the first input to be n and the length of the second string to be m. We've actually got a time complexity of n plus m, and the space complexity is going to be space. I don't know why I'm doing an s. The space complexity is going to be the same thing. It's going to be n plus m. All right, let's jump into the code. So the first thing that we want to be able to do is get a count of characters, or count for each character that we have in a particular string. So I might start off by making a private extension on string, and I'll make a computed variable called car counts, and this is going to return me a dictionary of character to integers. And what we want to do is, given a string, we want to produce one of these dictionaries where each character is representative of a character that exists in the string, and the integer represents the count of that character in the string. So I'm going to use the reduce into operator, and I'm going to reduce this into the expected output, which is a dictionary of character to integers. And in the reduce into, you have the partial result, and you've got the current. I might just call this car, and we're going to pass in the closure. So the first time we go through a character in this, the partial is just going to be, as a reminder, this is just going to be the empty dictionary that we've already provided here, which we've created. So we're going to say our partial character with a default value of 0 plus equal to 1. So if the character is A here, we're going to access A, and if there's no A in there, we're going to give it a default of 0, and we're going to increment that by 1. And once you've written that, you're pretty much done here. You can add the word return if you want to. I'm going to leave it there for clarity because sometimes that might confuse interviewers. Your interviewer may not be super familiar with Swift. So I'm going to keep that return there. And then what we can do in the actual isAnagram function, which is what we're trying to solve here, we can say s.carCounts equal to t.carCounts. And again, we can put the return keyword if you want to, but I personally don't use it in my own projects, but in an interview context, I might put it for clarity. So if I submit this, hopefully we're good. Unless I made a boo-boo. And it looks like we're good. All right. Hope you have a good day.